Welcome. In this session, we round out our list of primary rules of differentiation by determining the derivatives of exponential functions. This then includes all our basic functions, powers, logarithms, and exponentials. That gives us a complete list of basic rules of differentiation. The method we are going to use is a special case of implicit differentiation, which we'll see a little bit later in section 4. This method can be used to differentiate any function when we know the derivative of the inverse function. In this case, for the function y equals e power x, inverse is the natural logarithm, and we just saw what its derivative is. To use this method, take the equation y equals the function of x, in our case y equals e power x, take the inverse function. So in this case, that's same as saying write the equation in logarithmic form. So if y equals e power x, that means ln of y equals x. Then you differentiate both sides, treating y as a function of x. So when I differentiate ln y, then I have composition of two functions, first y, then ln. So when I differentiate that, I start with the outside function, which is ln. Its derivative is the reciprocal of what's inside it, so that gives me 1 over y. But then I must differentiate the inside. I don't know what the derivative of the inside is, so I simply write a placeholder, y prime. On the right hand side, I just have x, its derivative is 1. And typically when you differentiate an inverse function by this method, you get something times y prime equals 1. Then you solve for y prime. In this case, I cross multiply. I get y prime equals y. Now you write that in terms of x. Y is e power x. So derivative of e power x is e power x. E power x is essentially the only function with this property. You can multiply e power x by a constant, but anything else will have a derivative different from itself. And this is what's special about natural exponential function. It increases at a rate proportional to itself. Now, to differentiate exponential functions from e to some expression in the variable, we have to combine this with the chain rule. If I have e to the power u, where u is a function of x, then its derivative will be e to the u times du over dx. So if you have base e, derivative of an exponential is the exponential times derivative of the exponent. What about other bases? One method is to use the same technique from scratch, and that will give us the derivatives of a power x as a power x times ln a, and of a power u, where u is a function of x, as a power u times ln of a times du over dx. In general, for an exponential function, we get an extra factor equal to the logarithm of the base. Another technique which you can use to differentiate general exponentials is to write a power x as e to the power x ln a, using properties of exponentials and logarithms. It's important to understand the difference in terms of calculus between exponential functions and power functions. The question is really whether the base is a constant or exponent is a constant. To illustrate this, let's write down the derivative of e power x plus x power e plus e power e. E power x is an exponential function because the base is a constant. The exponent involves the variable. And we just saw a derivative of e power x is e power x. What about x power e? There the base involves a variable. The exponent is a constant. So that means I should use the power rule. The fact that e is irrational doesn't really matter. Power rule still applies. As long as the exponent is constant, doesn't involve the variable, the power rule applies. If both the base and exponent are numbers, the whole thing is a number. It's a constant, so derivative of that will be 0. In particular, derivative of e power e is 0. Of course, you might ask, what happens if both the exponent and the base have a variable in them? Then we have to use a different technique that we will see in section 5. Let me do one more example and stop there. Let's differentiate e to some expression. As the rule earlier states, To differentiate e to some function of x, take the exponential. So to differentiate e power x squared minus 2x plus 3, I have that exponential and then multiply it by derivative of the exponent. The exponent is x squared minus 2x plus 3. Its derivative is 2x minus 2. This is the basic fact you need to differentiate exponential functions. And next time we will use this to differentiate more complicated expressions involving exponential functions.